sharing very important aspect of our syllabus, that is space physics. So first I would like to give you an idea what is meant by space physics, what is space. I hope all of you would able to see diagram on screen. There is a universe. Universe is composed of consists of galaxies, right? Galaxies consist of solar systems, and in solar system there are stars, planets, moons, asteroids, comets, and meteorites. So first, very important thing, we are going to compare the we will do comparison with star and planet. Students, would you able to see a diagram, the comparison of star and planets on your screen?
Yes. So sir, this is solar system, right? Then the next chapter after atomic nuclear physics.
Actually,
right?
The section called space physics. There are two main sections: Earth and the solar system. Okay, so please let's take an example, students. Earth is a planet and Sun is a star, right? So there is very basic information which I would like to share with you. Please keep in mind, Earth is a planet, Sun is a star. So what is the difference between planet and a star? Number one, please keep in mind, star is a luminous object. Star is a luminous object. Luminous object is the one which emits star emits its own light, right? So we can consider star as a luminous object. Okay, so star is a luminous object, whereas planet is a non-luminous object. Okay, star is made up of gases, right? If we talk about Sun, it is made up of hydrogen and helium gases, whereas a planet is made up of rock, ice, gas, or water. So mainly planet is made up of rocks, whereas star is made up of gases, mainly gases, hydrogen and helium. Okay, planet orbit the star. It means planet revolves around the star. Okay. Whereas star don't have to orbit anything, right? Another thing is, planet is always cooler than the star. I mean that the surface temperature of the planet is less than the star, whereas star is the hotter object. The surface temperature of the star must be higher than the planet. Okay. One another thing, students, I hope I will send you.
Star system.
Excuse me, could you please repeat? Abdullah Kaisa, what do you want to say?
Ibrahim Kaisa, sir. Object is star system. What's a star system?
Okay. Star system actually, in our universe, right? There are galaxies, right? Galaxies made of solar system. In each solar system, there is one major star. That is the main source of heat and energy for the planet.
Yes, sir.
Okay. One very important thing, there is no nuclear reaction on the planet. Okay? No nuclear reaction. No nuclear reaction in planet. Whereas in star there is a nuclear reaction. Nuclear fusion. Fusion is a type of nuclear reaction. You know what happened in basically nuclear fusion? Two smaller nuclei of hydrogen combine and form a heavy nucleus, that is helium. Let me give you an idea. 1H1 and 1H2 combine to form the 1H1 plus 1H2 combine to form helium 2He4. Sorry, 2He3. There is an isotope of helium. Let me.
Can it also be 4 or we have to write 3?
It all depends on the isotopes of hydrogen. Let me write down another equation. Wait a minute, please. The actual equation is 1H2 plus 1H3. 1H2 and 1H3, these are two isotopes of hydrogen. They combine, when they combine, they fuse together and form the helium nucleus, 2H4. And it can be seen here, proton number is conserved, 1 plus 1 is equal to 2. Nucleon number is conserved, 2 plus 3 is equal to 4. 2 plus 3 is equal to 4. 1 plus 1 is equal to 2.
2 plus 3
is 5, right?
5, not 4.
Okay, right. And also, let me explain. There is a release of one neutron. In this process, there is a release of one neutron and also there is a release of energy. Right. There is also a release of energy.
That only going to be 2 plus 3 is equals to 4, right?
Yes. Because the neutron has nucleon number is of 1. The nucleon number of neutron is 1. Whenever there is a nuclear reaction, as I have told you, 4 parameters remains considered. Okay. Number 1, proton number, nucleon number, mass and energy, and momentum of a system. This is the main concept. So the major difference between planet and sun is, planet is a non-luminous object, star is a luminous object. Planet is made of rocks and star is made of gases. Planet revolves around the star. Students, have you noted down these informations?
What are these properties listed on the left side? What are these properties for? Proton number, nucleon number, mass and energy, What is this for, sir?
Yes. This is whenever there is a nuclear reaction, right? Occur. And you know, in the core of sun or on a star, there is a nuclear reaction. So I am just giving you information. You know, as you can see, in the core of sun, 1H2 plus 1H3. These two isotopes combine to form a helium nucleus, and also there is a release of one neutron plus energy in the form of heat. So here you can see proton number is conserved in this nuclear reaction, nucleon number is also conserved, mass and energy is conserved, and momentum of a system is also conserved.
Nuclear fusion reaction, right?
Yes.
Okay, sir.
Okay. Can we move forward now, students? Let me ask. Any questions, students?
No.
Thank you. There is a exam question. Okay, here. It's an exam question. Actually, students, in this question, we have to identify star, planet, and galaxy. Let me give you an idea. Students, the galaxy where we are living, the name of that galaxy is Milky Way. Milky Way is the name of galaxy where we are living.
Okay, sir, noted. Milky Way is the
Okay.
galaxy in which we live.
Yes. So here they are asking identify galaxy, planet, and star. Let's talk about the star. As we know, moon is not a star. Okay, there is only sun. Sun is a star, right? Planet, as we know.
Sir, what is moon? Moon is a planet, right?
Moon, yes. Yes, moon is a planet. For sun, moon is a planet. Moon is not a star because it is non-luminous. It don't have its own light. Okay, it is made of rock, so it is a planet. So here it can be clearly seen that for Sun, Earth, and Milky Way. If Milky Way is a galaxy, Earth is a planet, and Sun is a star. Yes, I would like to show you the hierarchy of the universe, students. First, stars, planet, moons. Okay, star, planets, and moons. Star, planets, and moon. Asteroid, comets, meteorites. These are celestial objects. Celestial objects are those that they can stay in space. Celestial objects are those they can stay in space. When they combine, they form a solar system. When more solar systems,
Moon is a planet.
actually we consider moon
Moon isn't a planet, right? Moon is not a planet, right? It's just a celestial body.
celestial body, but it has some properties of planet as well, like it is made of rocks and also non-luminous objects. Planet is basically a celestial body that revolves around the sun, or star in a fixed orbit. We will discuss more details. Just to give you an idea, for example, if we consider, for our address, as our address consists of city name, province, country, continent, and world. So our planet is our city where we live. Okay, and two or more planets form a star system, right? Country is a star system, continent is a galaxy, and world is act as a universe. So for Earth, star system is called solar system, okay, and more than more solar system combines to form stars, and more stars combine to form galaxy. That is the name of our galaxy is Milky Way, and two or more than two galaxies combine to form universe. As it is believed in this world, there are more universes. There is not only one universe. There are more than one universe in this world. These are the theories given by the Stephen Hawking in this century, latest century. The concept of Earth. What is the composition of Earth? So regarding Earth, few things please keep in mind. The Earth is the third planet from the Sun and is the only astronomical object known so far that is capable of sustaining life, right? So let me give you few basic ideas about Earth. Then we will, student, now I would like to discuss with you few basic information regarding the Earth. Number one,
Moon also has life, right? It has
non-luminous object. Moon is a non-luminous object. Moon is getting light from Sun.
It reflects light, right?
Reflection of light.
Okay.
Earth, third planet from the Sun, the main. Third planet from the Sun, and the main thing is up till now that what we came to now from research, it is the only astronomical object that is capable of sustaining life. Actually, for sustaining life, there are some requirements. Water is one of these, and temperature. Water, suitable temperature, and atmosphere. So that we can have only on Earth. That's why Earth is the only astronomical object that is capable of sustaining life. Right. The third very important information, and it is usually asked in MCQs as well. So Earth is from 150 million kilometers from the Sun. Okay, so distance from Sun to Earth, I mean average distance the Earth from Sun is of Earth from Sun is 150 million kilometer. 150 million uh, kilometer, the time from the sunlight to reach to the earth. So its take I mean 8 minutes and 20 seconds. Eight minutes and 20 seconds for light from the sun to reach Earth.
Sir, it says it takes 500 seconds.
Yes, that is equal to 8 minutes and 20 seconds. It's very important information. It was also asked in last exam as well. So it's highly likely it would be asked in your exam in MCQs or theory question. The time interval during which sunlight reaches from sun to the earth is 500 seconds. So 8 minutes and 20 seconds is the time interval for light to reach from sun to the earth. Student must note down this information. The next is Earth travels around the sun flattened circular path. We consider almost a circular path, right? And that path is called an orbit. And very important information, Earth takes 1 year, 365.25 days to revolve around its orbit. Actually, please keep in mind, student, Earth takes 365.25 days to to complete one complete revolution around the sun. Students, have you noted down these information? Can we move forward?
Sir, what's a flattened circular?
Actually, it looks like it's almost circular, but on the edges, on the on the horizontal axis, it is little bit flat, not exact circular. The Earth takes 1 year, (365.25 days) to travel around its orbit. Normal year is 365 days longer. The extra quarter day is adjusted in every 4th year called leap year that has 366 days. Let me explain that. I hope you have a very good idea about the leap year as well. In leap year, February contains 29 days instead of 28. So normal year is 365 65 days longer. The extra quarter day is adjusted in every fourth year called leap year. Leap year contains 366 days. That has 366 days. Okay. So why it has 366 days? Because February is of 29 days. I will send these slides to you after class, students. No worry about it. Okay. Let's talk something about the composition of Earth. Earth is a rocky planet, right? So it has almost 29% land, 71% water. Surface is made of several layers. You know, there are several layers known as tectonic plates. You know, when there is earthquake, tectonic plates disturb. So this is a theory. Okay. So you know, Earth is in a rotation and revolution as well. So what is a rotation? Rotation is moving about its own axis. For example, sometime we revolve football in our fingertips. So it's a rotation known as spinning. Okay. So spinning could be clockwise or anti-clockwise. So Earth is in a rotation or is in a spinning. So Earth rotates on its axis, which is a line through the north-south pole. One thing, student, please keep in mind, Earth's spin is anti-clockwise. Let me write down here. Earth is moving in anti-clockwise. All natural rotations in anti-clockwise, right? So Earth spinning is anti-clockwise. Okay. Other than spinning, its revolution, its revolve. So as we know, Earth completes its cycle or revolution around the sun in nearly one calendar year. Here there are few information, students. Period of rotation of Earth is 1 day, 24 hours. In 24 hours, Earth complete one rotation or one spinning about its own axis, right? So that's why we have in one day we have day and night, and period of revolution when it's revolve around the sun is 1 year, 365 days. That's why calendar is contains 365 days, and also in one complete calendar year we can have different seasons and summer and winter as well.
Sir, can you send these notes that you're right now?
Yes, I can send it. I will send it immediately. No worries. Okay, students.
Okay, sir.
Okay, sir. Thank you.
Welcome, most welcome. I will provide you each and every source. Students here, they would like to give you an idea. Yes, please.
I said thank you, sir.
Welcome. Let's say the star and there are two planets. Please keep in mind the time taken for one complete revolution for each and every planet is different, right? So some planet takes less days, some planet takes more days. For example, here we are considering an example, planet A. Planet A takes 10 days for complete one revolution around the star, and planet B takes 50 days. Okay, and they both start from the same point. Same initial position is the same. So what would be the position after 5 days, or what would be the position after 150 days? These questions would be asked in your exam. After that, I am going to show you as 10 days. So after 5 days, it will complete half revolution. Planet A will complete half revolution. So from it will reaches at this point, X, Y, Z, right? Whereas
half revolution, right?
Yes. Whereas planet B has a time period, it could be say time period that is denoted by capital T. Time period is time taken for one complete revolution. Okay. I would like to give you an example. The time period of the second hand of a clock is 60 seconds. After 60 seconds, it reaches its starting point. So planet B has a time period 50 days.
So can you repeat once again? What's 60 seconds?
Time period of the second hand of a clock is 60 seconds.
Yes.
So after 60 seconds, the second hand of a clock reaches its starting point.
Yes.
So same thing as time period of planet B is 50 days. Okay. So after 150 days, after completing a planet B, after 3 revolutions, it will reach its starting point. Is that clear?
After 50 days, the planet reaches its starting point, just like the second hand, right?
Yes. After 3 complete revolutions.
So sir, we're doing 3 times 50 because it completes
So what
in
is
3
the
days.
Yes. Actually, let me explain. T1 50 days. It will complete one revolution in 50 days.
Sir, what's your revolution, sir?
Excuse me, could you please repeat your question?
What's a revolution, sir?
Revolution is one complete round trip around the star. It is also known as one oscillation or one round trip. One complete round trip of a planet around the star. Is it clear?
Okay, sir.
Okay. So students, as just for experimental basis, they have given there is a planet called B. Its time period is 50 days. Okay. So in 150 days, it will complete 3 revolutions. And after taking 3 revolutions, it will reach its starting point. This is the situation. Are you clear about that, student? And also there is an example of other planet A. Its time period is 10 days. Okay. And after 5 days, it will complete half revolution. Half revolution. That is known as half round trip, right? Please keep in mind, students, one complete revolution, is 360 degrees, okay? And half revolution is 180 degrees. Please keep this information. Similarly, 1/4 revolution is 90 degrees. Similarly, 3/4 revolution is 270 degrees. Let me give you an important information. For example, this is our starting point for planet A. When it reaches at Z, it covers an angle of 90 degrees, 1/4. At Y, it covers an angle of 180 degrees. At W, it covers an angle of 270 degrees. And again, when it reaches its starting point, it covers the angle of 360 degrees.
So, sir, we're gonna use angles too?
You must have an idea that one revolution consists of 360 degrees. One complete round trip consists of 360 degrees. Exam question.
Sir, do we need to learn this formula of cycles equals to total time divided by period?
Yes. Total time divided. Yes. You must have. How many number of cycles? Number of cycle means one complete round trip. You must have an idea about it.
Sir, what's period?
Period, time taken for one complete oscillation. Capital T. Time taken for one complete oscillation. Okay, student. Question is, Earth, Jupiter, and Saturn are 3 planets in a solar system, and their orbital speed is given, and also their time period is given, time to orbit the sun in years. Earth is taking 1 year, Jupiter is taking 12 years, and Saturn is taking 29 years for one complete revolution. And here you can see this is Sun, Earth, Jupiter, Saturn, and direction of rotation. Student, can you identify all stars are in anti-clock? Downward. Okay, axis rotation. The direction of orbit is given. We can assume they are coming downward. Okay. So complete figure 2.2 to show the position of 3 stars exactly 6 years after the diagram in figure 2.1. 6 years. For example, after 6 years, Earth will complete its revolution. Okay? Earth will complete its 6th revolution. So Earth would be at the same point where it is after 6 complete oscillation. Jupiter will complete half revolution as Earth will complete 6 revolution. Jupiter will complete half revolution. Right. And Saturn will complete 0.21 cycle. I mean less than quarter cycle. Because 29 years, so in 6 years, 6 over 29 is equal to 0.21. So it can be clearly seen after 6 years, Earth would be at its same point, okay? Jupiter moves from here to here at this point on the other side of the sun after covering half round trip, half oscillation, and Saturn just covered less than 1/4 oscillation because its time period is very, very large. Student, would you be able to identify the position of a planet after certain time if its time period is given? Actually, we have to identify either the given time period planet covers one complete oscillation or half oscillation or 3/4 oscillation or 1/4 or less than 1/4 or greater than 1/4. This is our expertise. We will do more practice. We will continue this section space physics in this week and next week as well. I have sent you these all slides to the group, right? I will send further resource of space physics in your group as well. Students, do you have any question regarding today's class?
No, sir.
No.
Okay. Thank you very much, students. See you in the next class. Take care.
Allah Hafiz.
Okay. Goodbye.